Hi everybody. Hello Dion and welcome. What are we going to talk about today? IFC spatial structures. What is an IFC spatial structure, Dion?
So yeah, today we're talking about IFC spatial structures. It's quite again, it's still a relatively basic concept in IFC, but a very important one. And if you remember, we talked about how everything in IFC Foundation classes is a class. A spatial structure is just another bunch of classes. It's like a group of classes, you could call it that, that all serve a common purpose. And the common purpose they serve is to give a spatial structure to our BIM models. So an example of a spatial structure are things like buildings and stories and sites. So here I have a model, and if I just expand out the project tree here on the right-hand side, and I collapse all of these things, and this is a very messy IFC model, you can see here that we have inside our project, and remember last week we talked about projects, and the project is the very first class that you look at when you start looking at your IFC data. And inside of that, you can have many other classes inside of it. And some of these classes are known as spatial structure elements, or spatial classes, or yeah, I guess you could call it that. And they are, some examples of them are things like sites and building stories. And the idea is that all of your regular elements, a non-spatial element like a wall or a door, can be contained or organized inside a spatial element. So for example, if I go and expand out what's in the story, I can see that there are some objects here. So if I just zoom to that up, so this particular object that's highlighted belongs inside this spatial structure class. And this spatial structure class of a building story belongs inside this IFC building, and this building belongs inside this IFC site. And there are a variety of different spatial structures that can be used, but the most common that you're going to find in architectural projects are a site, a building, and a building story. And those are the exact terms which are used. Is that making sense so far?
Yes, yes.
So if I just go over here and when we first introduced classes, we talked about element classes, and those are things like walls and doors and all that. But if I switch my drop down here to spatial element, you can see what's available to us. And there's a few other things here which you don't see up here. One example is a IFC space. This is another word for this can be a room, for example, or an area. And another one we can see is a spatial zone, which is we won't get too much into that detail because it's not used as much. But as you can see, and there's one more as well, an external spatial element. These are like exterior spaces. If you have, for example, an external space like a garden, for example, or a something covered by something undercover, for example, or even not undercover, like a football field or something like that. That would be an external spatial element. So these are the classes that we'll talk about today. And there are a couple things which make it special. The first thing which makes it special is the fact that you can organize them in a hierarchy, just like this. I have my contents list for those who are interested in what we're talking about. So we just talked about, we're in this one right now, about what are spatial elements. And I'm going out of order here. So the one I'm going to talk about now is what is this? Multiple or complex spatial element trees. And the idea is that you can organize your spatial element in a tree structure, like a hierarchy, as you can see here. So this is inside that, which is inside this, which is inside that. And the reason I mention this is because many people don't organize their BIM files this way, and this is especially important when you're working on a large project like a compound for a university or a defense base or an office park or something like that.
Mm-hmm.
Often you would have one site or multiple sites, and within that site you would have multiple buildings. So you can see here on this site, there seems to be one site, and there are clearly two buildings next to each other. Unfortunately, I can only see one building here in my spatial tree. So if I right-click on that and I say select all the objects, you can see I have two buildings belonging inside one building. And that is a good example of a very common error or mistake that we see in BIM data, that people are not correctly assigning their elements to the correct spatial structure. And this is a problem when you want to do things like costing, or if you want to organize or run queries on it for scheduling. It becomes much harder because you cannot predict where your elements are going to be. You can't filter them out very easily. Does that problem make sense, and why it's something we should get right?
Mm-hmm. Mm-hmm.
The good news is that it's actually very easy in some programs to fix this. So, for example, firstly, this building doesn't have a name, so we'll call this building A, and we'll rename it there, and we'll create a new building. And in Blender, it's super easy to do this. You just create a new collection, and after that, you say, I'm going to have another building B, and I'm going to just duplicate building A and call it B instead. And now what I can do is, just for now, I will select everything in these two buildings. I will deselect everything over there. So this is now my building B. And I am going to move all of these objects into my building B. Now I still need to organize this into the correct stories, for example. But already, just by making this simple change, and you can see how simple that was. I just sort of dragged one into another. I can fix that up. And so if we continue to inspect this file, we can say, okay, we have a whole bunch of building stories. We have the -1 story, which I assume is a basement of some kind. So if we select that, you'll notice something interesting here. I've selected stuff that's on the -1 story, but it's selected elements that seem to go all the way up the building.
Yeah. And
if I isolate that, some of these make some sense. So for example, we have this wall, which ideally, and this is poor modeling, in that you should actually break up your walls per floor, just as you'd construct it in real life. But let's say, for whatever reason, that this wall actually was going to be constructed 3 stories at a time, and that's how this wall worked for, let's say it's a triple height space or something. The correct spatial element for it to belong to is the lowermost space. So in that regard, it is somewhat correct. Whereas this column, which seems to be split up in a very weird way, is clearly wrong. So, and we can just keep on moving along here and seeing whether or not these are correct or not. And it would give you a good idea of the general quality of BIM modeling that we see today. So here's another floor, and you can see again these incorrectly split objects. And this is something we should be writing in all our execution plans to say, hey, so that we can do things like scheduling properly or costing properly, please split this up properly. Here's another one with a very strange wall. And you can see just how simple it is to spot these types of errors. Another one here, and so on up until you hit the top of the building. And we have a story here which actually has nothing in it. So maybe that was on building B, but if there's nothing in it, and Oh, then we have one story just for these roofs. Okay, why not? Clearly something which can be improved, but this is often something that's not looked at very much. We tend to export things into IFC, and we don't actually check whether or not they're organized correctly. And a simple check just like this can spot lots of very strange mistakes. And it's not just costing and scheduling which this impacts, it also impacts facility management. So if you have objects which are meant to belong in a certain part of a building, if you don't have them in the correct spatial structure, so in this case, it's a building it's a building story, but in other cases you would have a space like a room. It should be in the correct type of space, and if you don't assign it to the correct space, then your asset register is not very useful. So, how's that for a intro? Is that still good?
Yeah, I have enough time to catch it up, so don't worry.
Okay.
Like I said,
quick break to the guys.
Like I told you already from before, I'll need to watch these videos at least 10 times again to understand everything.
Okay. A quick shout out to the guys watching. If you don't want to sign up to Twitch and you want to post questions, you can go to osarch.org, and on the top right, you can click on the live chat link, which will bring you to a live chat, which we'll check for any questions.
Yeah. So much plug-in for this community. Oh my God, Dion. In my face, you are doing it. No, that's good, guys. Just go there to live chat. Guys and girls.
It's a thinly disguised ad. Now, another thing to realize about spatial elements is that they're just like any other class. And like most other classes that users will deal with, it can actually have geometry associated with it. So for example, this site object actually has a representation or geometry. In this case, it's this piece of green thing. And many people don't realize that it is possible to actually have that. The building, in this case, I have building A and building B. If I zoom into building A is actually an empty object. It has no geometry associated with it. And that's not very good. And it may not matter, but there are interesting use cases. It may not matter in this particular scenario, but there are interesting use cases for storing geometry in there. So just to give an example, let's say if I just go in, okay, so I can create a new plane, and I will start going and model a brief, let's say a massing model of this building. So just a moment here. This won't take too long. Okay, done. So what I've just modeled here is a brief massing model of the building, and it's actually valid for me to call this IFC building A and delete that empty object instead. So that now my building not only contains all these stories and all the elements inside, but it by itself also has a geometry. And that's really good because especially if you want to have a large urban scale set of BIM models, this building representation is very good to use as context for massing, for shadow studies, for privacy studies, for 3D printing, for using as a template to create physical models out of. And this is a perfect place to store that information. And unfortunately, it's just not used to the degree that it really should be in IFC. But you can see just how easy it is. You just create a block and you call it a building, and that's pretty much it. Now I have building A. And so that's a good example of how you can have a representation. And a more common example of when you might have a geometry associated is if you have a space. So currently in this model, there are no spaces at all, which is a shame. Well, there's no objects at all. But let's say inside this particular room, I had a monkey, and this monkey was a very valuable asset, and I need to model the space of this room. And in this case, it's a relatively simple prism room shape. So I will just model something like this. If I just snap and snap. Okay, great. So now I have my room, which I can then say, okay, this is a space, so I'll assign that. And this, well, if I get my monkey, so just a moment. And this monkey will be part of that space. So if I go over here, I can, this monkey is not part of what should I call this monkey? A wall? Monkey-shaped wall? Movable wall. Why not? And he can be he can be contained within my space. And so for most cases, whenever you're in your BIM program, when you're creating rooms, it's actually generating that shape which I just drew, which in my case was this sort of cube-like thing. But it's important for people to check that. And very often, many BIM viewers actually hide this or make it invisible, so you can't see the geometry of these spaces. And so it's very important when you get an openBIM viewer that you get one which is capable of showing these spaces, so that you can check to make sure that the right shape, and if you're using it for energy analysis, they're the right. They go up to the right extents. And right room heights and so on, that they're fully capturing the things that are meant to be inside of them. So that's a good example, I think, of how spatials, where it's important, because to deal with the geometry of a spatial structure element, because most people tend to ignore them. They just say, okay, it comes out by default, but this often creates bad or incorrect BIM data. One more thing I want to mention is that these spaces, very often your BIM program will not actually give you a lot of control over how these things are created. So for example, what if I have multiple buildings? It's actually impossible to create multiple buildings out of Revit, for example. So in Revit, you're stuck with one building whether you like it or not. And that creates a problem in creating messy BIM data. Whereas in other programs, it might allow you to do it, but it may not be so obvious, or you might not have the same fidelity. So for example, it's actually possible to put a building inside of a building, and that way you can have multiple wings of a building. So to give you an idea, let's say I'll just create a big cube here. If this was one, if I change back to spatial elements, which we're talking about today, so I can call this a building, and there's a special element called the composition type attribute, and over here you can fill it out in a way that allows you to say that this building then contains multiple sub-buildings, and is currently fixed to 3 layers of hierarchy. And I haven't got it here at the moment, so from memory, I think the complex would be the top level building, so like a group of sub-buildings, and then you would have another building, which would be the element that's within that building, and then you would have, I forget what the third one is, maybe part or something like that. I'll have to double check. But the concept I'm trying to get across here is that you can have a highly complex tree starting from your project, leading down to a site or even multiple sites, and then one site, let's say it's a big compound, let's say a university plot, for example, could then be broken down into multiple sub-sites. And within those subsites, let's say subsite, you can have another building and building. What am I drawing here? Building. So you can see how it can get quite detailed in describing our urban environment just by organizing the spatial tree. And many of our BIM programs say, no, you're not allowed to do any of that. You're stuck with project, site, building, and then story 1, story 2, story 3. And if you want to do anything else, well, too bad. And they don't let you very easily change things like the geometry or so on. And that's no good. That's no good. If we want to create, especially, everybody's talking about this buzzword digital twin, and people don't realize that their BIM programs are even failing to describe sites and buildings, well, it's all talk. So maybe that's something we got to fix. Mm-hmm. Sorry, I went on a rant there. How are we going? We're still tagging along, still yes, going good?
All good.
Okay, I wanted to talk about this. So remember how a long time ago we said how IFC classes, which users care about, they're called rooted, and what that means is that they all have a global ID. So if I click on this, I can see that it has a global ID. I click on that, it's got another global ID, and so on. Yes. Now, a global ID is pretty special when it comes to spatial structures, because very often, especially when you have a large project, you create multiple IFC datasets. And so what often happens is that you have your project here, and then your project has multiple, in this case, you create multiple IFC files, which is very common. And you have one file created by the architects, one file created by the mechanical engineers, one file by the electrical and civil and hydraulics and so on. And each one of those are separate files, right? And where's here? I forgot structure. Okay, there's the structural engineer. He's very important. So now each one of these creates their own IFC file. And inside each one of these files, they create the exact same definition. They create the definition of a project, which has a site, which has a building, which has building story 1, building story 2, and so on. Is this sounding familiar? You ever run a project like this?
Yeah.
Petru?
How other
I've lost you.
No, I was very focused on what you were
Okay, but this is fairly stereotypical, right? I mean, yeah. you end up not with just one IFC file. You end up with 1, 2, 3, 4, 5. So let's say 7 or 8 or 10 IFC files, and each IFC file copy pastes this data.
Yeah, same.
And what we all haven't you ever stopped to think how crazy that is, that we're copying and pasting the same data 10 times, and you know what happens when you copy paste 10 times? People get it wrong. So the structural project's called 1, 2, 3. The architectural project is called foo. The mechanical guy is left it blank because he's not interested. The civil guy, he doesn't even have a building because he's just on site, and his site is called something totally different. And so you have 10 IFC files, all with different spatial structures. Oh, and I should mention, it's not just the names which are different, it's the data within them. So for example, if I jump into a building story, so if we, let's grab let's find a building story. Okay, building story. Oops, if I spelled it correctly. So if I click on this building story, you can see it has an elevation. So this is a height, a real height. And you can see how this is in one file, but very often what you'll find is that the structural engineer has one set of heights defined, the architect will have another set of heights defined, the mechanical, has copy pasted a few, and so it's a huge mess. It's a really, really, really big mess, and all that comes from a lack of understanding of how to organize and reference the spatial structure. So what needs to happen is not only do we need to have people understanding that the spatial structure is just, if not more important than the individual walls and the doors and the pipes and all that, but we need to know who has the authority over it and how to reference that authority.
Appointed party,
and IFC,
maybe?
Yes, and IFC has mechanisms of designating who has the legal ownership over entities and has the source of truth over whether this is called 1 to 3 or whether it's called foo, and whether this elevation is set to 2 or whether it's set to 2.25. All of those things can be set in IFC. But that now we're getting a little bit complicated, but the very first thing you can do to get it right is for everybody to agree that the project, the site, the building, and each story has exactly the same global ID. So this global ID can be changed. I can generate a new one. So at the start of a project, we should generate a global ID and say, okay, everybody, this is the global ID of the building. And this file is the master file. It has it defined here with all of the attributes like name and long name and composition type and all that. And everybody else must match this global ID. And by convention, in IC5, it'll be a bit more advanced, but currently by convention, if the global IDs match, it knows that when you combine these 10 files together, it will say, oh, look, this building, this site global ID is the same as this site global ID, and it will merge them.
Mm-hmm.
And that way you don't have the same thing defined 10 times. You can have a truly federated model. If you're not doing this, you're not really federating. You're kind of just like giving people the same data copy paste. Yeah. So that was my little rant on global IDs and why it's just so important to get that data right and to emphasize to people that that's the whole point of a global ID. It's unique.
Yeah.
If you refer to two different things, yeah, they should be unique. But if you're referring to the same thing, in which case these guys are, they should be the same. And so please figure out how to change it in your respective BIM applications. In Blender BIM, it's easy. You can just type it in. Obviously, don't type that. I mean, it's pretty important how. Yeah, you can paste it in, right? Somebody can give you a value, and you can go paste it in the right field. Anyway, let's undo that a little bit. There we go. Yeah, so that was my rant about the global ID. There are some really cool attributes that spatial structure elements have. So, for example, it has a name and a long name. This trips people up. The name of the so a good way to understand this on what to fill it up. Again, this is just an ad, right, Petru, for OSR Wiki? Every time I'm just going to point to this page.
Yeah.
Here we are. Spaces. Maybe it's here. No. Don't know. Oh, I know where it is. This is the micro MVD stuff. I should share this link. We'll share this link later on. So is it project setup? Naming? I don't know where I put all this stuff in. Oh, I can't think. Anyway, I don't know. I don't know where I put all this stuff. But there are rules on how you should fill all the stuff. The name should be the short form name of the building. So, for example, if it has, it's a short name. It's not meant to be the full long name. Like the full long name might be an address. It might be like 13 Foo Street. And then maybe the short one might be 13 Foo. If you use a project code or something like that, or something that's embedded in your drawing codes and things like that, that's what you should use in there. Elevation is pretty obvious. You get that on building stories. I'm obviously editing a building story here, which is not what I should be editing. But elevation is pretty obvious. If I go to a building and site, they have a special attribute which allows them to store an address. And a few other, before we get to the address, you'll notice some other things like elevation of reference height and elevation of terrain. These are things like the greatest height datum of the site. So if I had a sloping site, for example, the highest point that was around the building would be, I think, one of these. I have to check which one. But if they're not important to your project, you can ignore them for now. But one that is important is the ability to store an address. And so you can basically say what type of address it is. So I don't know if this is office address. You give it a description, and these are all typical address fields. You don't need me to tell you how to fill that stuff up. So that's good. There is one more thing I wanted to point out, which is, so that's done, the geolocation attributes. So when you look at a site object, a site can have a few attributes. In this case, in this particular file, it's empty, it hasn't been set. But you'll notice one saying ref latitude, ref longitude, and it does have ref elevation set to 0. And this is important because many people see that and they think that if they fill it in, they're geolocating their file. This is not correct. The ref prefix stands for reference. And that's a good way of thinking about it, in that, yes, you can fill this out in latitudes and longitudes. So that would be, so in Sydney, it'd be negative maybe 33, 31, something. I don't know. Maybe 150 something. I don't know what it is in your part of the world. But this is not the same as geolocating. This is simply used to so that somebody can easily figure out, in general, where your project is in the world. If you want to truly geolocate your file, you need to use a proper coordinate reference system. If you fill out those on an IFC site, if you fill out the ref latitude and longitude, that does not mean you're geolocating your file. My IFC site is all the way up here, floating middle of air. So if I fill that in, it's saying that that particular point floating up there is 0, negative 31, 150. And this is an issue because many people, many BIM programs don't show where your site is, or they don't show you where your building is, right? Over here, I can click on a point and I know that this is the exact point in the world where my building story originates from. And same for my site and same for my building. But very often in BIM programs, for some bizarre reason, they hide that from you, the origin point of your building, the origin point of your site. And that creates a problem if you want to accurately know where to set your values like these. And I guess the best advice I can say is start using programs which do support it. But until then, there are various workarounds, which you can find, of course, on the OSArch wiki, which will guide I guess we'll give you an idea of where all that data is stored. But if all that's a bit confusing, hit export and check out in Blender BIM. It's free and open source, works cross-platform, Mac, Windows, Linux. Just download it and see where it ends up being. So yeah, I guess that was covering my last point, is the object placement. And that's kind of what I meant, is that the spatial elements are actually real things which have a location in the world. So yeah, cool. Yeah, I guess that was it.
Did we get any questions?
I will throw one quick thing, which I forgot to add to my list, that there are more extensions to IFC now, which allow you to create a spatial structure for things which are not buildings. And the term they're now using is something called an IFC facility. And there are now things like bridges and infrastructure elements that you can add, because obviously a bridge is not a building. So now there's an actual IFC spatial class called an IFC bridge, but unless you're using the very latest version of IFC, that will not be available to you. And this is a good reason why, if you're still stuck on 2x3, you should at the very least move to IFC4 because you're missing out on a whole bunch of really good data that you could otherwise use to structure your BIM.
Is Blender BIM using the latest version of IFC?
Correct. It's using the latest ISO approved version. So it's not actually using the latest, and I'll explain what that means. So if you go to technical.buildingsmart.org and you click on the specifications page for IFC, when this thing loads, here we are, IFC specifications database. You can see that some of these have been approved as an ISO standard. So this in 2017 was the latest ISO standard approved one, and this is what's supported in the Blender BIM add-on. Same with this one here, which is 2x3. Most people are still stuck in this one from 2007. I highly recommend you upgrade to the one from 2017 because then you'll only be 4 years old.
What about with the more recent ones? What about those from 2020?
Yeah, so these are RC stands for release candidate, and that basically means it's still a little bit of a work in progress. They're still massaging it and getting the new data in there. But for example, if I opened up that one, you can see that it has a lovely picture of fancy infrastructure stuff because that's the that's some of the new stuff that they're adding. And if I go and take a look under spatial element, you can see, look at this. It's got bridge, marine facility, railway, road, parts of a facility. It's exciting, this new stuff.
Yes, indeed.
Anywho.
Yeah. I think we got a question regarding use of Blender BIM or Blender to scan to BIM. Any tips?
Well, that's a very broad question. I'm not really sure how to answer that. The short answer is that Blender can convert any geometry from any source into openBIM data.
Maybe point cloud. Maybe if you can do some work with point cloud.
Yes. I'll start with the general answer first, and I'll talk about point clouds for a bit. So, in some BIM programs, the tool you use affects the object that you can create. So for example, if you use the wall tool, like let's say I had a wall tool here. So this is my wall tool, for example, and I'm here modeling my wall and so on. Now, your BIM program may say that because you use the wall tool, you can only export it as an IFC wall. That's an artificial restriction placed by the vendor. It's not actually a restriction in IFC. IFC doesn't care about the wall tool. All it knows is that there is geometry. So Blender doesn't have that restriction. And from my understanding, programs, for example, ArchiCAD also doesn't have that restriction, I believe. And these are good things. These are the things you should be looking in a BIM program. It's the ability to classify any geometry as anything, and that's extremely important for scan to BIM. So this object, even though I use the wall tool to model it, I could call it whatever I wanted. Let's say this was, I don't know, some form of, I don't know what this is. My imagination's run short, but you can call it anything you want. And so, yes, you can absolutely use it for scan to BIM. Another really important aspect you might need in scan to BIM is the ability to work with meshes. And Blender is an exceptional mesh modeling package. So, for example, if I go in, let's create a simple mesh here, and I'm just going to subdivide it a few times. And this is using stuff like, I think Rhino is starting to copy some of these features, the subdivision surface modeling, but it's very useful when you're dealing with scanned stuff. So you might get very irregular meshes or meshes which kind of taper a bit and are not perfectly plumb or 90 degrees are aligned. And that's very common in scan to BIM. And sometimes people recreate that using BIM software, but because all of the modeling tools are very, rigid, you kind of have to make things orthogonal. Like I can't just say, okay, here is, let's say here is my column, but actually, it kind of like does that. It's not It's just not quite right. And you see how that's kind of like a wonky column now?
Mm-hmm.
And like that took me a split second to do in Blender, and especially if I'm working from point clouds, I can do that very easily. And sometimes it's extremely important, especially for infrastructure work, where you don't want things to be plumb. You want things to be reflecting what it truly is in real life.
Mm-hmm.
And it may not look so beautiful on a plan, but that's the reality. Real life isn't so beautiful. Real life is kind of messy, especially when you're working with scanning to BIM for heritage items, it's important to be able to work very, very easily with meshes. To be able to mark a point and say, that point actually comes out like that. That stuff is incredibly inconvenient to do in non-mesh modeling packages.
Mm-hmm.
And then once you've done that, you can call it anything. But I guess there was also an allusion to point clouds. IFC can store point clouds, and I don't want to delve in too much detail about it. The short answer is that Blender supports it. It's one of the very few applications which can support exporting point clouds to IFC. In fact, I don't know of any other application which supports it, probably none. But it's highly experimental.
Mm-hmm.
And to be blunt and honest, it's at the moment it is only useful if you are also using another experimental technology called HDF5, which is beyond the scope of today's discussion.
Mm-hmm.
So in theory, yes, it exists. Blender does support it, but maybe wait a bit before it becomes a bit more user-friendly.
Yeah.
Unless you like that type of thing, and in which case go for it, and we can talk more.
I see. Let me check. Do we have any other questions from the chat? No.
I don't see any other questions in the chat. No.
No. So that's good. Everybody understood everything today, so that's very good.
We hope.
Yeah. Yeah, cool. Then no point in prolonging this. Sorry about the technical problems. Yes, we are not CNN. I'm sorry about that. I'm hoping you will forget us for this and join us next time as well. Dion, by the way, do we have a teaser for the next time? Like what else do we need to cover in the next sessions? And when are we starting with the most exciting things after that? Because after that, we plan to start with something hands-on stuff.
Well, maybe we should do some hands-on stuff. I mean,
we'll definitely. The plan is to do it. The plan is to do it when we are done with the theory. How much of the theory do we still have?
Oh, there's no end to theory. So how about we just take a break and we do something to do with we can do a practical exercise next time, like how to find how to audit an IFC file for incorrect classes, something like that.
Yeah.
To start cleaning up BIM data.
That sounds good. And maybe we don't need an hour for this. Maybe we can cut it to half an hour, or if needed for more chat afterwards to have.
Yeah, definitely. Yeah.
The presentation to be around half an hour more at the most, right? And if needed, we can stay longer for questions.
Yeah.
Yeah, that sounds good. Well, thank you very much for today.
Cool. See you guys.